Hi students, today we are going to study inverse Z transform methods. So basically there are four methods to find the inverse Z transform. First one is long division method, second one is partial fraction method, third is residue method, and fourth one is the convolution method. Okay, so here we are going to discuss about long division method. If x of z is given as the ratio of two polynomials, then its inverse can be found out using long division method. So x of z is given as a polynomial, the ratio of two polynomials. So here we are applying the polynomial division methods. Okay, so let's see one example. So first question is, using long division, determine the inverse Z transform of x of z is equal to z plus 1 divided by z square minus 3z plus 2. If x of n is causal and if x of n is anticausal. So we need to find the inverse Z transform of x of z. So inverse Z transform of x of z means x of n. Okay, so we are having two conditions. First one is causal and the second one is anticausal. So we have to find that. Okay, so so first case is causal. So when x of n is causal, then begin with the division starting with the highest power of z. So how will we find whether the signal is causal or anticausal? That is we are discussing here. So in order to find the causal x of n. Okay, so when x of n is causal, so causal x of n, we need to divide these two polynomial in the order that where highest power of z comes first. So if we look into our question, it is given as, let's look into the numerator polynomial. So it is z plus 1. So what is the higher power of z in that polynomial? It is 1. So z plus 1 is like given in the say, expected order, and when we look into the denominator polynomial, it is z square minus 3z plus 2. So here what is the highest power of z? It is 2. So the question as such given us in the k condition for the causal. Okay, so in first case we don't need to rearrange the polynomials, just we have to perform the polynomial division. Okay, so we have to divide z plus 1 divided by z square minus 3z plus 2. So first we have to do, we need to take the first two terms z, and here it is z square. So what we have to do is we have to divide z by z square. So what will we get after dividing z by z square? It is z raised to minus 1. So we are writing that answer. What answer? The result we obtained from dividing z by this z square, we are writing in the top portion. Okay, so then next step is, first is division, then it is multiplication. Okay, so in multiplication what we have to do is, so in this multiplication, we have to multiply this z raised to minus 1 by all these three terms. So we have to multiply the entire polynomial on the left side with this z raised to minus 1, and we have to write it here. Okay, so in first step we have to multiply z raised to minus 1 by z square. So what is the answer? It is z. Then next term is minus 3z into z raised to minus 1. So what we will get? Minus 3z into z raised to minus 1 means minus 3. Then next term is 2 into z raised to minus 1. So 2 into z raised to minus 1. So we have to consider this as a single polynomial, and we have to perform subtraction. We have to subtract z minus 3 plus 2 z raised to minus 1 from z plus 1. Okay, so that is z minus z, that is 0. Then next term is 1 minus minus 3, that is 4. Then here there is no term for z raised to minus 1, so we can write 2 z raised to minus 1. So this minus comes inside, then it will become minus 2 z raised to minus 1. So that term comes like that itself. So again we have to do the same steps. Okay, so what we have to do is we have to divide this 4 by z square. So what is the answer for 4 by z square? It is 4z raised to minus 2. So that we have written here. Okay, next step is first is division, then multiplication, then subtraction. So next step is we have to multiply this 4z raised to minus 2 with the polynomial z square and minus 3z plus 2. So we will get the answer like this. Then what we have to do, we have to consider this as a single polynomial, and then we have to subtract this polynomial from this one, 4 minus 2 is raised to minus 1. Again we will get another polynomial, and we have to divide this term by z square, and we have to write that here. Then we have to multiply this term from with this term, and we have to write the answer here. Again subtraction, we have to continue like this, and you have to perform this multi process up to a four or 5 terms. Then you have to put etc. Okay, so this process continues. So finally we have to write the answer. Okay, so it is, we will get x of z is equal to z raised to minus 1 plus 4 z raised to minus 2 plus 10 z raised to minus 3 plus 22 z raised to minus 4 plus etc. It goes like that. Okay. So now what we have to do is we have to take the inverse z transform. Okay. So from the basic Z transform functions, Z transform pairs, we know that the inverse Z transform of Z raised to minus m is delta of n minus m. So if we apply that formula here, we will get x of inverse as inverse of x of z is x of n. Here it is of the form z raised to minus m. So z raised to, in the place of m it is given 1. So z raised to minus 1 means delta of n minus m, that is n minus 1. So we have to write like that. Then from that we have to list the coefficients of the impulse functions, that is 0, 1, 4, 10, 22. So how here there is no 0 term is there, then how it becomes 0? So that is delta of n minus 1 means the value of the x of n at n equal to 1. So we have to start a function from its 0 origin. We have to denote the origin point. So here there is no term for del of n, because the answer starts at del of n minus 1. Like that it goes n minus 2, n minus 3, n minus 4, etc. We have to begin it from the origin. So here there is no term, so we have to put that as 0. Okay. So here I have shown the basic equations for finding the inverse. Okay. So this is all about in case of a causal sequence. When x of n is causal, we have to perform the uh, steps like this. Next comes the anticausal. So given that x of n is anticausal, then what we have to do that, we know that if the signal x of n is non-causal or anticausal, then begin with the division starting with the lowest power of z. That is that we are having two polynomials, that is numerator polynomial and denominator polynomial. In case of causal x of n, we started with the polynomial division with the highest power of z, both in numerator and denominator. In case of anticausal, what we have to do that we have to rearrange the polynomial from the beginning as the lowest power of z, like that. So our question will be changed to x of z is equal to z plus 1, change it to 1 plus z, and z square minus 3z plus 2 will become 2 minus 3z plus z square. Then again we are performing the polynomial division that is mentioned just before. The same steps we have to follow, just the order of the polynomials are changed. And again we are writing x of z. So in last, when we are taking the inverse, it was like in the form of z raised to minus m. So here it is in the form of z raised to plus m. Okay, so that is z raised to plus m means z raised to minus of minus m. So the delta function will be del of n plus m. So like that we have to take the inverse. Okay, so and here we are since the signal is anticausal, so our origin will be at the extreme right end. Then we have to represent the inverse coefficients of x of n like this. Okay, so this is how we have to find the inverse Z transform using long division method.